Welcome guys to the channel. If you haven't subscribed, kindly do so and remember to click the notification button to get more amazing content. And with that, let's go straight to the video. During a congressional hearing last week, Republican Representative Louie Gohmert of Texas asked a U.S. Forest Service official if our organization or the Bureau of Land Management could change the orbit of the moon or Earth to reverse the effects of human-caused climate change. And is this possible? First, we must take a stock of what we have, the givens in what will be our equation for moving the Earth. Our planet orbits the Sun at an average distance of 149.6 million kilometers, and it soaks up enough sunlight to have an average temperature of about 15 degrees Celsius. The latter figure is, however, an increase of slightly more than 1 degree Celsius from Earth's typical temperature across the past century. In short, this world is running a low-grade fever. According to current consensus estimates, that fever is likely to get much worse if left unchecked, raising Earth's average temperature by another 1 degree Celsius by the 2060s. Such an increase will render some presently people-packed parts of the planet effectively uninhabitable and threaten the sustainability of global civilization as we know it. Radiative equilibrium, the balance between incoming energy from the sun's rays and energy emitted from the Earth, is key to our understanding of our planet's changing temperature. It is described in the following equation. Albedo measures how well our planet reflects solar energy, where 0 will be perfect absorption and 1 will be perfect reflection. There is a connection between climate change and albedo. Snow and ice, for instance, have a high albedo, reflecting up to 90% of the sunlight that hits them back to outer space. Anthropogenic warming causes snow and ice caps to melt, which can make Earth's albedo decrease. That in turn eventually leads to a higher average planetary temperature. Some variables in these equations are changing naturally. Our star is very slowly swelling and brightening, becoming slightly larger and more luminous as it ages. Ethan Siegel, a theoretical astrophysicist and science writer, says that while it will take the Sun on the order of 100 million years to increase luminosity by 1%, our greenhouse gas-emitting global civilization is projected to increase the solar energy retained by Earth by 1% over the next few hundred to 1,000 years. To make Earth cooler, we need to decrease a variable on the right side of the equation. We can't easily lower the Sun's temperature or radius, and clearly meaningful reductions to our heat-trapping, albedo-shifting greenhouse gas emissions are out of the question. So let's simply increase x, the distance to the Sun. All we have to do is find a way to move all 5.972 septillion kilograms of Earth's mass further away from our star. A 3 degrees Celsius decrease in temperature to counteract current and near-future anthropogenic warming would require us to move our planet at an additional 3 million kilometers from the Sun. Using another back-of-the-envelope calculation, we find that 5 times 10 to the power 31 joules could push all kilograms of Earth's mass 3 million kilometers out from its present orbit. These numbers present challenges for Representative Gohmert's plan because annual global electricity production is around 10 to the power 19 joules. That's also assuming we can apply all that energy to Earth at 100% efficiency, which thanks to the laws of thermodynamics is physically impossible. Setting aside such particulars, we haven't addressed what form this applied energy would take. There is the literal nuclear option. One method that scientists have proposed to move an asteroid is to detonate a nuclear bomb near it. Scharringhausen says it will basically vaporize part of the asteroid, and that escaping rock vapor acts like rocket exhaust and will push the asteroid along. Scaled up, such a mechanism could in principle provide enough oomph to shift a planet's orbit. Still, it will take 1 billion times more nuclear explosions than we have ever set off to move Earth the required distance, or the equivalent of dropping an atomic bomb every second for 500 years. According to Geza Gyuk, director of astronomy at the Adler Planetarium in Chicago, the strategy of constantly detonating nuclear bombs near Earth's surface with the goal of vaporizing parts of it to act as a rocket exhaust also has several drawbacks. For our purposes, the most notable deleterious effect is that the blasts themselves will heat up the planet, counteracting the stated goal of reversing global warming. A gentler option would be to siphon off the energy of other celestial objects, such as passing asteroids or comets, by engineering close planetary flybys. This technique is regularly used in reverse with great success by spacecraft that boost their speed by passing close to a planet to steal a portion of its orbital energy. For moving our planet, the issue with the method is scale, Siegel says. The total mass of the asteroid belt is only 4 to 5% of that of the Moon, or 0.05 to 0.06% that of Earth. Using the mass of the entire asteroid belt in flybys would migrate Earth away from the Sun by less than 748,000 kilometers, or a quarter of the distance we'd need. And a single off-course collision with our planet would spark destruction, approaching that caused by the asteroid impact that eradicated the dinosaurs in a global mass extinction. Fortunately, we have a much more massive space rock sitting in our backyard, the Moon itself. Could they cut the gravitational string connecting the moon to the Earth, thereby slingshotting our planet into a wider orbit? Not in any way that we are capable of doing today, Siegel says, and the consequences will be disastrous. Besides having greatly reduced tides, a moonless Earth would have much darker nights, shorter days, and extreme unpredictable seasons because of the stabilized axis of rotation. What if instead of getting rid of our natural satellite altogether, we only change its orbit around Earth? Increasing the radius of the moon's orbit by 10% would affect Earth's own trajectory around the sun in the long term. We could extract and accelerate material off the moon using a 100 gigawatt laser or one with about the power capacity of every single wind turbine in the US. It will take 300 trillion years to lift sufficient amounts of material from the lunar surface. There's always the aforementioned nuclear option too, which could be used to move the moon rather than the Earth. Another less messy choice will be to manually extract lunar material with conventional rockets. If we were able to build a spaceport on the moon and build a rocket equivalent to SpaceX Falcon Heavy to lift off moon material into deep space, we would need 7 times 10 to power 16 launches. That's 70,000 trillion rocket launches. For comparison, during the entirety of the space age, humankind has only managed to achieve 70,780 launches, and more than half of them did not leave Earth's atmosphere. Humans could add a twist to the use of asteroids in the flyby idea and instead put them on a collision course with the moon. We will need kilometer-sized comets to crash into the moon every second for a couple of 100 years to make a substantial difference, though an off-course projectile could cause a planetary mass extinction event. Because of the magnitude of the change necessary to increase the Earth's orbit, any intervention will probably need to last for many millions of years at minimum, which raises an unexpected sociological issue. We don't have precedent for planning across such vast timescales, and in fact, no civilization in human history has endured more than a mere few thousand years. Finally, even if humans managed to alter our planet's orbit using any of these methods, they wouldn't be able to rest easy. If we even somehow could make this enormous change in Earth's orbit, it doesn't absolve us from the responsibility that we'll keep needing to make this change as long as we keep increasing the greenhouse gas concentration in our atmosphere. It's a Sisyphean task in which humanity is Sisyphus, and the boulder being eternally pushed uphill is Earth itself. Thank you once again for watching the video. I hope it was informative. Kindly like, subscribe, and click the notification button.